Hey everyone, welcome to the Chapter 1 Functions Test Review video walkthrough. I'm going to be going over the test questions on the review. You can check out the review in the description below or go to my website, mrhernandezteaches.com. So let's get right into it. In our first question, we're given f of x equal to x squared plus 2x, and we want to find a minus 3. So where I'm going to substitute a minus 3 in for wherever I see an x value. Wherever I see an x value, I'm going to replace it. So this becomes a minus 3 squared plus 2 times a minus 3. And then what you don't want to forget for this a minus 3 squared is what it means. This means a minus 3 times a minus 3. So then we're going to want to distribute. A times a is a squared. A times negative 3 is negative 3a. Negative 3 times a is negative 3a. And negative 3 times negative 3 is positive 9. We can combine these two middle terms to be negative 6a. So that's for this a minus 3 squared part. So this is going to be equal to a squared minus 6a plus 9. And then we also want to distribute this 2a minus 3. So plus 2a and 2 times negative 3 is minus 6. Combine any like terms that you still have remaining. So a squared negative 6a plus 2a is going to be negative 4a. And 9 minus 6 is going to give me positive 3. So this could be an answer that you're going to be looking for on your test. Moving on to question 2, finding the zeros. What you want to think about here is in a graph, the y values for x-intercept or a 0 is going to be something comma 0. So the y value is 0. Remember, f of x is equal to y. So all we need to do is substitute 0 in for this, and we're going to get 0 equal to x squared minus 3x minus 108. And then what you're going to want to do right after this is going to factor that quadratic. So don't forget any different ways that you can solve for the function will do. As I'm thinking about negative 108, I'm thinking of two values that multiply to be negative 108 that combine to be negative 3. And the two values that come to mind are going to be negative 12 and 9. So x minus 12 and x plus 9 equal to 0 are going to be my factors. All I need to do with those is called the zero product property and set each of those separate factors equal to 0. So x minus 12 equals 0 and x plus 9 equals 0. And these are going to give me the zeros of my function. So add 12 to both sides, we get x equal to positive 12. And subtract 9 from both sides, we get x equal to negative 9. Both of these are going to be the zeros of that equation for f of x. Moving on to question 3, find f of negative 9 for this piecewise function. So x is negative 9 in this case. So I want to think about this part over here first, because as we're going through it, we're going to want to say, all right, so is negative 9 less than 1, or is negative 9 greater than or equal to 1? So we're thinking here in this case, negative 9 is less than 1. So I want to substitute negative 9 in for the x only in the first equation. So let's do that. Negative 3 times the absolute value of negative 9 plus 5. We just need to solve for this. So negative 9 plus 5, that gives me negative 4. The absolute value of negative 4 is positive 4, so this becomes negative 3 times 4. And negative 3 times positive 4 is negative 12. And that's going to be our solution for number 3. For question 4, what is the definition for an odd function? So there are a couple things that you're going to want to remember. An odd function is a function that kind of does a rotation around the origin. So what I'm talking about here is I can take this little piece off on this end, and I can rotate it around and it'll be the exact same. So an odd function is symmetrical around the origin. But another thing that you're going to want to keep in mind, especially for function notation, is we're going to substitute in a value for negative x, and whatever the x becomes, we should get a negative y. So negative f of x. So this is part of that definition for an odd function. Moving on to question 5, we have the height in feet of a flare is modeled by h of t equal to negative 16t squared plus 104t plus 1.5. And we want to find its average speed from 4 to 6 seconds. Okay, so average speed or average rate of change, we're looking at the equation y2 minus y1 over x2 minus x1, the difference quotient, the average rate of change. And in order to get y2 and y1, we're substituting in 6 and 4 for this function here. So let's go ahead and start doing this. I'm going to find first h of 6, so negative 16 times 6 squared plus 104 times 6 plus 1.5. So 6 squared is 36, and then 36 times negative 16. And that is going to get me negative 576. So negative 576. And then 104 times 6 is 624 plus 1.5. And then let me see if I can simplify this. So 624 minus 576, borrowed there, that'll be a 1. So 6, 8 is going to get me 14, and 61 minus 57, that'll get me 4. So 3, 4, yep. So 48 plus 1.5, that'll be 49.5. All right, so now for y2, I have 49.5. Now I also got to find y1. So let's see, y1 is going to be the same thing but with a 4. So negative 16 times 4 squared plus 104 times 4 plus 1.5. So 4 squared is 16. And 16 times negative 16, that's going to be 256, so negative 256. And 104 times 4, that's going to get me 416 plus 1.5. And then I want to subtract those two, so 416 minus 256 cancels. 41 minus 25 is 160. So 160 plus 1.5, and remember I'm going to be subtracting this. 160 plus 1.5 is 161.5. And then in my denominator, I'm doing 6 minus 4. So this is x1 and this is x2. Now we just need to simplify this a little bit. So 161 minus 49, because the 0.5s are going to cancel out. Let's see, this can be 15. That gets me 2. 15 minus 4 is 112. So I have negative 112 divided by 2. And then negative 112 divided by 2. We can simplify that to be negative 56. And I also want to keep in mind the units. The numerator is in feet and the denominator is in seconds. So negative 56 feet per second. All right, moving on to number 6. I think I changed this one. This should be reflected in the x-axis. But write a function for the graph for square root of x, translated left 3, expanded vertically by a factor of 3, and reflected in the x-axis. So being translated left 3, we know that's going to be square root of x plus 3 because you add it inside the function. Expand vertically by a factor of 3. So that's where we're multiplying by 3. And then reflected in the x-axis, that's where you make this a negative. So that's going to be our equation right there. So we could just call this y equals negative 3 times the square root of x plus 3. So being able to take the verbal description and combine it into the written form. Here we have question 7. F of x is x on x plus 2 and g of x is 3x. We want to find f minus g of x. So in order to do this, we're just going to subtract the 2 and simplify. So f is x over x plus 2 and then minus 3x. Now in order to simplify this, you want a common denominator. So if I want to make x plus 2 down here, I have to multiply this numerator by x plus 2. So let's go ahead and distribute 3x into here. Let's see what happens. So x over x plus 2 for the first fraction minus 3x times x is 3x squared, and 3x times 2 is 6x, all over x plus 2. Well, when we are subtracting, now that they have a common denominator, we're going to subtract, but we do want to distribute that negative. So this is going to say x minus 3x squared minus 6x, because you distribute the negative, all over x plus 2. And then if we just want to write this in standard form a little bit, this becomes negative 3x squared, x minus 6x, that'll be minus 5x, all over x plus 2. Alright, here we are moving on to question 8. If f of x is x squared plus 1 and g of x is 1 over x, we want to find the combination of fog of x. So f of x is x squared, and we just want to substitute that into x. So remember, if fog of x, that means f of g of x. Well, g of x is 1 over x, so we can replace that now. So f of 1 over x. Well, now wherever in this equation, wherever I see an x, instead of x, I'm going to substitute in a 1 over x. So now it's going to equal 1 over x squared plus 1. And we can simplify this a little bit. The square goes to the numerator and denominator. So 1 squared is 1 over x squared plus 1. That's going to be f of g of x. Moving on to question 9, we have find the inverse of f of x when we have 1 over x minus 2. So remember, start by writing this as y equals 1 over x minus 2. You want to swap your domain and your range, so x equal to 1 over y minus 2, and then you want to solve back. So I have division. When I have division, I want to think multiplying, so multiply by y minus 2 on both sides. Right, those divide out, and now I have y minus 2 times x equal to 1. I want to isolate the y that we have over here, so I'm going to take this x away. It's saying multiplying by x, so I want to divide both sides by x. Those divide out, and now I have y minus 2 equal to 1 over x. Now all that's left to isolate my y is to take this negative 2 away by adding it to the other side. So y equals 1 over x plus 2. Remember, you do want to write this with the proper inverse notation. So the inverse of f of x is equal to 1 over x plus 2. This should be your final answer. For number 10, writing a function that is 1-to-1. You can write many functions that are 1-to-1. And then, so something we could write is 1 over x. You could also write just x. That function is also 1-to-1. Anything that passes the horizontal line test, the HLT, is going to be good here. We could even write square root of x. Something that won't work here, something that isn't 1-to-1, is x squared. So you don't want to write something like that. For question 11, we want to determine the domain and range of the function y equal to absolute value of x plus 3 minus 2. So all I want to think about is, where does this graph happen? The absolute value function is the one that looks like a V. So when we're working through this problem, we want to think about what are the transformations that are happening. So this means we're moving to the left 3 and down 2, and then it's making a V from that spot right there. So what is the domain and range of that function? Well, the domain doesn't change. So the domain is still negative infinity to positive infinity. It's the range that changes in this case. And the range starts in the apparent function 0 to infinity, but since we subtracted 2, our range is going to be including -2, comma, infinity. And that'll be our range for question 11. For number 12, what is the continuity test? And you need to use limits in your answers. So the definition of continuity, and it's specifically using limits. Well, let's look at this. If I have some function, right, this function is not continuous, but we want to fill it in at that point. Now it's continuous. So let's name this a, and then if this was a y value, this would be the function at a, f of a. So we need to use a couple of ideas. We need to say the limit. So the limit means as we're getting close to a from both sides. So the limit as x approaches a of our function f of x, that needs to be equal to whatever the function's value is at that point. So right there. So it needs to also be equal to f of a. This right here is the limit definition for continuity. In question 13, we want to estimate and classify the extreme of this function here to the right. So we have extrema, those are maximums and minimums. So I have a maximum here, a minimum here, a maximum here, and a minimum right there. So as we're going through it, we could say, all right, this one is a relative max because no point is higher than it in this area. Sorry, if there was, these points are higher over here, but it's not in this area. We're only looking at a peak. So that relative max is -1, comma 2. And then I have a relative minimum, not an absolute minimum because there are many points that are lower, but this is at the bottom of a valley. So we could say a relative minimum at what looks to be about 0, comma 0. Then I have another maximum right here that looks to be about 0.5, comma 0.5. So I just say I also have it at 0.5, comma 0.5. And then another relative minimum down here that looks like it's about 2, comma -4. So 2, comma -4. And that's all you have to do for estimating and classifying the extrema of the function. In question 14, is f of x equal to x to the 4th plus 2? Is that even, odd, or neither? And here you're going to want to use that definition. What happens when I substitute in a negative x? So if we do this, I'm going to substitute in a negative x. This becomes negative x to the 4th plus 2. But anything to the 4th power has to be positive. So this is going to be equal to x to the 4th plus 2. Nothing is affecting that 2. So notice here that I have the exact same thing as the original f of x. So when I substitute in a negative x and I get the original y values out, that means this function is even, and this is the work that you must show. Moving on to question 15, we want to write an equation matching this graph right here. So first thing I want to do is get this vertex. All right, so this is 2 to the right and 3 up. I also notice that this is a V shape. So V shapes, I'm thinking of absolute value. Not only do I notice that is that this function is also flipped upside down. Normally absolute value opens up, but this function is opening down, and it has a negative slope down 1 over 1, down 1 over 1. So the slope isn't really changing, but it is opening down. So if I'm writing everything out, I like to start with this vertex that is moving to the right 2 and up 3. So to move to the right 2, I need to do the absolute value of x minus 2. That is what moves me to the right. And then if I'm going up 3, I just need to add 3. And then the next thing I need to do is take into account the slope, this -1 slope, and that's going to be the a value outside. So that's the equation that'll create this graph on the right. And finally, moving into the open response question. You want to investigate the inverses of the functions that are going to be here. So we want to find the composition of f and g and the composition of g and f for each pair of these 3 functions here. So I'll put f of g of x over here, and I'll put g of f of x over on the right side for each pair of functions. So f of g of x, or f of g of x, is going to be x minus 3 plus 3, which simplifies to be x. And g of f of x is going to be x plus 3 minus 3, which also simplifies to be x. In our next pair of functions, if I substitute g of x into f, I'm going to get 4 times x over 4. Well, those 4's divide out, and I'm left with x. And then over here, I'm going to have 4x over 4, and again, those 4's divide out, and I'm left with x. And then for this last pair of functions, if I have f of g of x, if I have the cube root of x cubed, I'm going to have, well, the cube root and cube, those divide out, and I have x. And then over here, if I had the cube root of x to the third power, those cancel out, those are inverses, and I have x again. So that is the composition for each pair of functions. Moving on to part B, we want to describe the relationship that we just found. For each of those, they all came out to be x. So all of those compositions to be x. Or we also know this as its parent function, the linear function, also known as the identity function. So that's all you need to say about that relationship. For C, let me scroll to the right a little bit. Graph each pair of functions on the coordinate plane, then graph the line of reflection by finding the midpoint of the segment between corresponding points. So in our first one, I'm just going to throw us out some sketches. So in our first one, we have x plus 3 and x minus 3. So x plus 3 is going to be this. X minus 3 is going to be this. So then that point of reflection is going to be right there. Again, the line y equal to x. In our second graph, let's see what we have. We have 4x. So it's going to be here. 4x, and then we have x over 4. So there. Pretty close. And then the line of reflection is going to be going straight through the middle. Again, the line y equal to x. And then lastly, our last sketch, we have the cube root of x. Sorry, that one's x cubed, and then we have the cube root of x. Let me try that again. There we go. And again, that line of reflection is going to go straight through the middle, y equal to x. So that's what we want to see, 3 graphs for that one. And the compositions are equivalent to which parent function? We kind of answered this in B. They're all equivalent to the linear graph or the line y equal to x. So we could just say linear function, linear parent function, also known as the identity function. And for this problem, we want to find what makes the composition equal to x. So really, we kind of just want to find the inverse of these functions. So if I see minus 6, I want to think about, okay, g of x in this case could equal x plus 6, the inverse of that. And then for this one, x over 3, well, that one's saying dividing by 3, so I'm going to want multiplying by 3. Here, this one says x to the 5th. So x to the 5th, we're going to want the 5th root of x. Here, I'm multiplying by 2 and subtracting 3. So I want to add 3 and then divide by 2. And then our last one, we want to subtract 1 and then take the cube root of that. So that concludes our test review. I hope everything is going to be helpful. Make sure you're able to do this review without any help. So make sure if you do need help, you watch this video and then you go and try it on your own without the video on a separate sheet of paper. But thank you guys for watching. My name is Mr. Hernandez, and I'm always here to help.